Hello, welcome to the 2019 Scholarship Calculus video tutorial, I guess. Let's get into this. I'll just adjust the screen size. My working is more clear. So, question 1a, consider if x equals x squared take away 2x plus 1 over x take away 1 plus x squared plus 2x plus 1 over x plus 1 where x is real. State the values of x for which if x is differentiable. So, x is differentiable where, so for a function to be differentiable, it must be continuous, and it must be a clean curve. So, for example, but this will most likely be like in a graph. It'll probably where x equals 1 and x equals -1. The graph will go like this, and probably I don't know what the graph looks like, but it will go off to infinity like this. So if x is not, if x as, so at x equals 1 and x equals -1, if x does not have a limit, so if brackets x, if x does, actually it's if x is not, I should probably question 1a, is not continuous at x equals 1 and -1, therefore if x, but anywhere else will be a nice curve, so anywhere else apart from x equals 1 and -1 will be differentiable. So if x differentiable for every value apart from x equals 1 and -1. That is question 1a done. Question 1b, I might want to make this a bit bigger. Question 1b, consider if x equals natural log of -x minus 2 all squared where x is real. State the values of x for which if x is real. So if x, natural log of a function is, for a natural log to be real, it must be greater than 0. Natural log of 0, actually, limit of its natural log of 0 approaches, limit as x approaches to 0 of natural log of x is -infinity, because natural log goes like this in a graph. So, but negative x minus 2 squared, when a value is, so when value is squared, it will always be positive. So when a value is squared, it will always be positive, and it can also be shown as a graph, since it will always be like this, and it'll always be at or above 0, and even at 0 always be, I shouldn't say positive, greater than or equal to 0. for natural log to be real, it must be greater than or equal to function inside must be greater than or equal to 0. No, not greater than or equal to greater than 0, since negative infinity is not real. But because of the negative sign here, it will always be but because of negative sign in front of x minus 2 all squared, it'll always be a negative or 0. And because since it'll always be negative or 0, therefore no value of x can satisfy if x being real. That is question B. Oh, oops, I dropped my pen. So question C, we have 6 books to distribute to 3 students, A, B, and C. How many different ways are there distributing these 6 books? If A is given 1 book, B is given 2 books, and C is given 3 books. So question C, I. So this is a combinations? Yeah, combination question. So so a combination, for combination, it does not matter what order it goes in. If it matters what order things are given, that is called a permutation. But in this, it's just asking different ways of distributing 6 books, so it's just a combination. So to person A, we can give 1 book out of the 6 books we have. So the first will be, so we have 1 book we have to give 1 out of the 6 books, so it'll be C 6-1 times, then we need to give 2 books to person B, so 2 books, but we already gave 1 book to person A, so 6 minus 1 is 5, so there are 5 books to distribute out of to person B. Then to person C we give 3 books, and 5 minus 2 is 3, so there are only 3. So there are 3 books to distribute to person 3, but that is actually just 1. Let me get my calculator out. Oh, where is my calculator? Oh, here. 6-1. And by the way, this is in your formula sheet. The combinations will be your formula sheets. 5 factorial. Wait. Yeah, 5 factorial times 2 factorial all over 4 take away 2. Actually, I might just write it out. So this will be equal to, so C in R, combination of in R is equal to in factorial all over in take away R all factorial times R factorial. So 6 factorial all over 6 take away 1 factorial times 1 factorial times 5 factorial all over 5 equal 2 factorial times 2 factorial times 3 factorial over 3 take away 3 factorial times 3 factorial, which is literally just 1. So this is 6. By the way, this is actually just 6. This is actually just 6. 4 take away 2 factorial times. Oh no, that's it's 5 take away 2. Factorial, which is equal to 60. So there are 60 ways to distribute the books to person A, B, and C with those conditions. Question 2II. Question CII. Each student is given 2 books. So person A gets 6. So they gets 2 books, and there are 6 books to distribute. Then the person B gets 2 books. Then 6 take away 2 is 4, and so there'll be 4 books to distribute. Times C 2, and there are 2 books to distribute for person 2. So this is actually just 1. So 6 factorial over 6 minus 2 factorial times 2 factorial times 4 factorial over minus 2 factorial times 2 factorial, which is, by the way, there's a way to write like this in your graphics calculator. It's a very easy way. So, but yeah, 6 factorial times 6 take away 2 all factorial times 2 factorial times 4 factorial over 4 take away 2 factorial times 2 factorial. Wait, what? What do you mean syntax here? What? Okay, yeah, which is equal to 90. That is question, the C down. Question 1D. Okay, so I'm pretty sure you can just test out the critical points for this. So let's just say case 1. When x is, let's say when let x equals -1. So then that will be -1 plus 1 absolute value, take away absolute value of -1, take away 4. Oh yeah, take away 4, which is equal to 0, take away 5, which is equal to -5, which is not less than, which is not greater than 1. So -1 is unapplicable. Then there's no case to the x equal to the x equals to 4. The x equals to 4, so 4 plus 1 absolute value take away, so value of 4 take away 4, which is equal to 5, which is greater than 1. Then I'm pretty sure you can just continue. We just at the critical point, so yeah, I think we can just do more guess and check with this. I'm actually not entirely sure. This is what my teacher said. So let x equal to x equal to I should do case 3. Let x equals to 2. Absolute value of 2 plus 1 take away absolute value of 2 take away 4, which is 3 take away 2, which is equal to 1, which is greater than or equal to 1. Then and then we can test x equals 1, which is absolute value of 1 plus 1 take away absolute value of 1 take away 4, which is 2 take away 3, which is negative 1, which is not greater than or equal to 1. And I think we can just wait the end. Wait, can I get a new page? Okay, yeah. So we can just say okay, just say y is equal to 2x. Wait, just x equals wait, let me just test x equals 0 here. Absolute value of 0 plus 1 take away absolute value of z take away 4, which is equal to 1 take away, which is equal to 1 take away 4, which is equal to negative 3, which is not less than, not greater than or equal to 1. So 2. So y is equal to 2x take away 3. For it to be, and since it will linearly increase, so 2x minus 3 is equal to 1, and so x is equal to 2, and for any values above 2 it will just continue to increase positively. Therefore where x is greater than 2, the equation is true. And question 1a. Okay, so question 1a. Given that 90 degrees is less than a and less than 180 degrees and sine to about 4, a plus cosine to about 4a is equal to 2/3. Find the value of sine 2a. So we can so sine So we can convert this into sine squared a plus cosine squared a all squared minus 2 sine squared cosine squared a sine squared a cosine squared a is equal to 2 over 3. So sine squared a plus cosine squared a all squared is equal to 2 over 3. Yeah, 2 over 3 plus 2 sine squared a cosine squared a, but then sine squared plus cosine squared just turns into 1, so and this 1 squared, so 1 is equal to 2 over 3 plus 2 sine squared a cosine squared a. So 2 sine squared a cosine squared a is equal to 1 over 3. I think it would just be easiest to go half 4 sine squared a cosine squared a is equal to 1 over 3, and this is just so 2 sine 2 on a sine 2a is equal to 2 sine a cosine a. So sine squared 2a is equal to 4 sine squared a cosine squared a. So half of sine squared 2a is equal to 1 over 3. So sine squared 2a is equal to 2 over 3. We square root that, and we need to remember the plus minus. So sine 2a is equal to plus minus square root of 2 over 3. And how should I? Can I be bothered simplifying? Yeah, which is square root of 6 over 3. But remember, the question said 90 degrees. 90 degrees is less than 180 degrees. So 180 degrees is less than 2a less than 360 degrees. If we look at a sine curve, here is 180, here is 360, so this value is negative, so between 180 and 360 will always be negative, so the plus sign is invalid, so the plus value is invalid, so sine 2a is equal to negative square root of 6 all over 3. Question 1 done. Let me just take a note on what time it is. Yeah. So 24 minutes and 20 seconds for question 1a. So question 2a. So square root of x take away 2 all over x take away square root of x all over square root of x take away 2. That can be simplified into square root x take away 2 over square root of x take away square root of x over square root of x, take away 2 is equal to k over 4. Make the denominators the same, so cross multiply, so x take away 2. Yeah. Over square root of x, square root of x take away 2, take away x over square root of x take away 2 square root of x equals k over 4. Negative 2 over square root of x squared take away 2x is equal to k over 4. 4 over x squared take away 2x is equal to k squared over 16. What values of k? 16 times 4 is 6. 4 is equal to k squared. X squared take away 2k squared. X, so k squared x squared take away 2k squared x. Take away 64 is equal to 0. Then we take the discriminant. B squared minus 4ac is less than 0 for it to be for imaginary roots. So b squared, so minus 2k. B minus 2k squared all squared. Take away 4 times k squared times negative 64, which is equal to 4k to about 4. Take no, that's plus, the times plus 256k squared is less than 0. Yeah. No, actually, let me just equate it to 0. That's much easier for me to work with. 4k squared plus 256 is 0. K squared. Is that 64? I think so. 256 divided by 4 is 64, yeah. K plus 64 is equal to 0. K squared is equal to negative 64. Yeah, so since it creates an equation with because this creates a imaginary soul for all values of k where all values of k will create imaginary roots. Okay, so question 2b. So log x squared log, let me just this base 10, so I'm just going to ignore that. It's equal to 1 plus log 10 13 log x take away y equals take away log, wait, is this both x take away y? I remember, what? Wait, no, that's, what? Why does that say take, what? It's, okay, no, that says plus. No, yeah. Log x plus y take away log x take away y is equal to 3 log 2. So, x squared plus y squared. So this one can be rewritten as log 10 10. Yeah, all of us will have a base of 10, so log 10 10. So log x squared plus y squared is equal to log 10 plus log 13, and basic log rules. So these multiply, so log 130. Then using, so which creates the equation of x squared plus y squared equals 130. This is equation. This is equation 1. Yeah. Then log x plus y, take away log x minus y. Basic log rules, you can bring this up to here. So which is equal to log 8. Then x plus y. And then yeah, log rules again. Log x is equal to log 8. So x plus y, x take away y equals 8. Since we can just cancel this out. This is equation 2. We can rearrange that. So x plus y equals 8. X take away 8y. 9y is equal to 7x. Yeah, let's just rearrange it for x. So 9y over 7 is equal to x. We place this into here. So 9y over 7 all squared. So y squared is equal to 130, I think. Yep. 130. 63y. Oh no, that's 81. 81y squared is equal to over 49 plus y squared equals 130. 81 plus 49. Right, is that 130? Yeah, it is. 130 y squared over 49 is equal to 130. Those two cancels out, so y squared equals 49. Y equals plus minus 7. Then we plug this into here. So actually we plug this into here. Actually, and the 7's cancel out, so 9y over 7 equals x. The 7's, if we plug 7 into y here, the 7's, the denominator cancels that out, so x equals plus minus 9. So x equals plus minus 9 and y equals plus minus 7. But logs must be positive, since if they are not, some people will call it sussy. So let's just, yeah, so x plus y must be greater than 0. So minus 9. Because x plus y is greater than 0, negative 9, where x, negative 9, negative 7 will not apply. Therefore, only solutions is 9, 7. Question 2c. So, find the area enclosed by y squared equals x squared take away x to the power 4, where x and y are both real. The graph of this relation has been provided below. Thank you. So, we want to rearrange it for y. So y equals square root of x squared take away x to the power 4. But this is now like this. So from here to here is 0, here is 1. So we can integrate square root of x squared take away x to the power 4 from 0 to 1. And all of this are exactly the same. They will have the same area because of symmetry. I don't know. So we can just say 4 of these is equivalent to the whole area. 4, we can tidy that up to 4 square root of x squared, square root of 1 minus x squared, 4 integral from 1 to 0, x square root of x square root of minus x squared dx, let u equal to x squared, I think. Oh no, never, no, let u equal to 1 minus x squared du dx is equal to minus 2x du, I think. Oh no, never mind. No. Du over 2x. Du over minus 2x. So, so we need to replace the limits. So where x equals 1, so u equals 1 minus x squared. So the upper limit will be replaced by to 0 because 1 minus 1 squared equals 0, and 1 minus 0 squared equals to 1, so that is the lower limit. So 0 to 1, u to the power of half x u to the power of half du over negative 2x, 4 of that, negative 4 integral from 0 to 1, these two cancels out, so u to the power of half all over 2 du. We can flip the limits here if we take the negative away, so 4 integral of 1 to 0, half u to the power of half. You can take this out, 2 integral from 1 to 0 u to the power of half du, which 2 over 3 u to the power of 3 over 2 from 1 to 0, 2 brackets 2 over 3 take away 0, which is equal to 4 over 3. This is a very tricky one. I do not like this triangle. Why did I opt in to do 2019 question? Oh well. I despise this triangle. So let's create a better scale. Let me just redo that one. Good enough. A dash, B, B dash, C dash, P, A, and C. So we let this triangle BPC. So area of this is equal to the perpendicular distance here. Right, was I correct? Wait, let me just check the marking schedule, I'm sorry. Yeah, Okay, we let triangle BPC is equal BBC equal to x2 triangle CPA equal to x3 and triangle BPA equal to x4. So let's see. So no wait. Hopefully we don't run out of anything. So we get triangle. So area of triangle BPC is equal to wait. Oh no, we get and the big triangle, the big boy one, the triangle ABC. Triangle ABC equals to x1. So let me just okay, so equal to x1. So x2 over x1 is equal to half times BC times this altitude. By the way, this all goes to the center. Let me just clean it up real quick. So this my OCD is just okay. It's good enough. So half times BC times this altitude from this altitude, which is so half. So altitude, yeah, this altitude, altitude of P to BC over half times BC times and the big area of the big one is the altitude of here. So half times BC times altitude of A to BC. This cancels out. x2 over x1 is equal to, yeah, altitude P to BC over altitude of A to BC. Actually, let me just use this diagram. Can I not zoom in? So this here and this here. So this, but this let me see. How do I say it? This angle and this angle are both right angle, and they're both from this. Can I just draw a new one? can I just draw a, is there a possible way to draw a straight line? Oops. Appears not. So this triangle and this big triangle one all comes from this angle, therefore, and they both have right angles, let's just name this part a dash dash. Let's name this part p dash. So p so here and here, p and a dash, and here was p dash, I think, a dash dash, p a dash all over a dash dash is equal, right, p a, oh no, p a dash over a dash a, to me, p a dash is equal to a dash a is equal to p dash a over p dash p dash p dash, no, huh? Wait, let me think about this. Right, p dash a over p over a dash dash a dash, right, p a dash over a dash. Actually, we do have this. Right, yeah, actually we do have this here. Dash over a dash a. P, right, no, altitude, oh yeah, no, because altitude from P, BC, and this is equivalent to this, so this is equivalent to this, so that we just proved that P, so we just proved that P dash, P a dash from here to here over, so we just proved from here to here over here to here is equivalent to here to here. Okay, so then we just do this with the other three. So right, so x3 over x1 is equal to half. Wait, what would CPA? Let me just rub this out. So x3 half CPA, yeah, half times CA times altitude of P to CA all over half times CA times altitude of B to CA, which is cancels out. Altitude from P to CA all over altitude from B to CA. This is now, let me clean this. So, the right angle here and the right angle to here. And this triangle and this triangle will be similar. So, we call this, let's just call this P dash dash and B dash dash. P dash. Oh yeah, okay, so basically can I redraw here somewhere? So we got this here, this triangle, and this triangle, both of them. So this point is P dash dash B dash, and this point is B dash dash. Oh, I'm sorry that I'm making this confusing. So B and B over, right, so B so B to P dash dash over P to P dash dash is equal to B to P dash, oh no, not, let me just create another triangle here, and create another triangle here, P dash dash and B dash dash, so P, B, oh no, P to P dash dash over B to B dash dash is equal to, no, not B to B dash dash, P to P dash dash over B dash to P is equal to B to B dash dash all over B to B dash dash all over B dash B, and then we rearrange this to get P dash dash over B dash dash is equal to B dash P over B dash B, and this is So we got this, and this length. So we got altitude from P to CA is this, or over altitude to B to altitude to P to P CA is this, and altitude from B to C A is this, and then we said that this is equivalent to B to B dash dash over B dash B. Then we arranged to get to say that B dash P over B dash B, and this is the area, and this is the area of x3 over x1. So this is the area of this. Okay, so we do this again. Okay, so basically this is the area of x2 over x1. We do this again. So x4 over x1 is equal to half times AB times altitude of P to AB, all over half times AB times altitude of C to AB. So cancels out, which is equal to altitude of P to AB all over altitude of C to AB. Then we get, so let's create a triangle. So this angle triangle, and this angle triangle. So let's just call it P dash dash and C dash dash. P over P to P dash dash. Altitude of P to AB, yeah, and altitude of C to AB is C dash dash. I know, yeah. Yeah, because of just, and then using similar triangles. To P dash dash C dash dash to C over P C dash to C dash C. And this is the area of x4 over x1. Then let area of x1 equal to 1. They'll mean then x3 over x1 plus x2 over x1 plus x4 over x1 is equal to 1. Then we got x3 is equal to b dash. Then x3 is equal to b dash p over b dash b, or b dash, plus we got x2 as pa dash over a dash a, pa dash over, or a dash, plus x4 we got here pc dash over cc dash, which is equal to the area of 1. Cursed triangle question, I hate it. On to question 3. So differentiate using first principles. So So, we differentiate using first principles. So if x is equal to x squared, take away 4x plus 3 all squared. So we insert, so if 4 is equal to 4 squared, take away 4 times 4 plus 3 all squared. These two cancels out. Just 3 squared, which is equal to 9. Then brackets x plus h. X plus h all squared, take away 4 times x plus h plus 3 all squared. X squared. Oh no, we put 4 in here. 4 plus h all squared. Because we want if 4, so yeah, by the way, so yeah, this is 4, this is 4. 4 plus h squared plus 8h, yeah, plus 16, take away 16, take away 4h plus 3 all squared, which is h squared. These two cancels out, plus 4h plus 3. We square all this again. Actually, I might actually just if brackets 4 plus h, take away if brackets h over h. So the limit of h to 0 of h squared plus 4h plus 3 all squared, take away 9 all over h. Right, it's a h squared plus 4h plus 3 all h to the power 4 plus 4h to the power 3 plus 3h squared plus 4h cubed plus 8, 16, 16h squared plus 12h plus 3h squared plus 12h plus 9. H to the power 4 plus 8, h to the power 3 plus 22h squared. To be honest, these numbers actually don't matter too much. We just include them because we have to. It's 24h plus 9. So if dash x is equal to lim is h approaches to 0 of take away 9 over h. So lim is h approaches 0 of h to the power 4 plus 8 h to the power 3 plus 22 squared plus 24h over h, which is equal to the lim as h approaches to 0 of h to the power 3 plus 8h squared plus 22h plus 24. And we can just essentially just plug that in, plug zeros in for each, and we get 24. To be honest, I don't have my calculator on screen, but I'll just test it out again. derivative of x squared plus take away 4x plus 3. Yeah, x equals 4, which is indeed 24. A point is moving around the circle with the coordinates of p are 3, 4. The y coordinates is decreasing at the rate of 2 units per second. At what rate is the x coordinate changing in the time? So we want to implicitly differentiate. So question 3, is it B? So implicit differentiation 2x plus 2y dy over dx is equal to 0. Dy over dx is equal to negative x over y. So that's 3, 4. Yeah, which is at 0.34, which is negative 3 over 4. So using kind of chain rule, dy over dt times dt over dx is equal to dy over dx dy over dt times dt over dx is equal to negative 3 over 4. So 2 times dt dx is equal to negative 3 over 4. Right, so when the y coordinates are decreasing, so negative 2. So dt over dx equals 3 over 8, dx over dt equals 8 over 3. Okay. Another cursed question. Question 3c. An ecologist is doing research at a national park. She must frequently travel between two hearts A and B, which are 4 kilometers apart. Halfway between A and B is square lake of each square root of 2 kilometers, as shown in the following diagram. The ecologist can tramp across land at 3 kilometers per hour, and there is a boat with a very small outbound motor that she can use to cross the lake if she wishes. The boat goes at 2.5 kilometers per hour. The x be the perpendicular distance of a point from the line AB is shown in the diagram above. The boat's path CD is parallel to AB. Where should the boat be positioned so that her journey between the huts take the minimum time to complete? You must establish that your solution is indeed a minimum. So, if this distance is x, then this distance is also x. So, and if this is square root of 2, then this whole distance is 2. So the distance between here to here can be modeled by is equal to, so that this distance so basically this is 2, this distance is 1, this distance is also 1 since the lakes are 4 kilometers apart, and so this is yeah, so The distance from AC can be modeled by using Pythagoras' triangle. 1 plus x, since 1 plus this part is x, so 1 plus x all squared plus, and yeah, just x squared, square root of that. That is distance from AC, but we have two of those, so 2 square root of, I'll just simplify that, 2x plus 2x plus 1. That's the amount of kilometers. And the distance from C to D is just, it will just be 4 take away 2x. I mean 2 take away 2x, I believe. And so the total time will be 2 square root of 2x squared plus 2x plus 1. That takes 3 hours. Yeah, 3 kilometers per hour. So this takes 3 plus 2 take away 2x, and this takes 2.5. We want to differentiate this, so yeah, so differentiate. This is such a pain to differentiate. So 2 brackets 4x plus 2. Oh yeah, and then we've differentiated over 3 square root of 2x squared plus 2x plus 1 plus, actually that would be minus 2x over 2.5. Oh no, that's just minus. It's not 2. It's not x, minus 0.5. So t dash, we set this to 0, so 4x plus 2 over 3 square root of 2x squared plus 2x plus 1 take away 4 over 5 is equal to 0. 4x plus 2 over 3 of 2x squared plus 2x plus 1 is equal to 4 over 5. 20x plus 10 is equal to 12. Square root of 2x squared plus 2x plus 1. This is becoming a really box number. 400x squared plus 60x plus 100 is equal to 144. 2x squared plus 2x plus 1. 400 take away 400, equal 288. 122x squared. 60 take away 288. Is 228x. minus 44 is equal to 0. Is that all divisible? No, that's not all divisible by 4. Is it? No, it's not. 61x squared, take away. Take away 11 is equal to 0. Wait, did I go wrong somewhere? This feels wrong. Right. Let me just 61 minus 57 is 11. I got 1 point. Wait, no, this is definitely wrong. Let me just check the marking schedule. 4x plus 2. Take away 2.5. So 4x plus square. Then 4x plus 2, which is 30. 4x plus 2 over 3. Take away 4, which is 12. 12 square root. So 400x squared. 20x. Wait. Oh, wait, did I go? Or is that y? Right, 400x squared. 4x plus 2 is equal to 4 over 5, 12 squared. 20x plus 10. 20x. Oh, wait, no, that's like 300, isn't it? Right, let me do it like the marking schedule says. So 4x plus 2 is equal to 2 over 2.5 since we set t dash to 0. 2.5 because 4x plus 2 is equal to 6 square root of 2x squared plus 2x plus 1. So we square this side, which is 36. 2x squared plus 2x plus 1. Then we 2.5 squared brackets 16x squared. Wait, what's 2.5 squared? No, that's 2.5. 16. Yeah, that okay. 16x squared plus 16x plus 4, which is equal to 100x squared. 2.5 squared x squared plus 100x plus 25 is equal to 72x squared plus 72x plus 36. 28x squared plus 28x take away 11 is equal to 0, I believe. Then we just put it in our polynomials in the calculator, which gives which gives minus 7 plus minus 3 square root of 14 over 14. And we need to, which is equal to 0.3017 or negative 1.301, and we can just ignore this negative. So 0.3017 and right 0.3017, and we should where x is equal to 0.3017, that's where it should be placed. It's so t dash is equal to 4x plus 2, 4x plus 2 over 3 square root of 2x squared plus 2x plus 1. T dash dash is equal to 4, oh no, that's 12. 12 square root of squared plus 2x plus 1, take away 4x plus 2 times what's the derivative of that? Let me just 2x plus 1 all squared. Derivative of that oh no, it's going to be times 4x plus 2. Right. X plus 2. Right. So 3 squared. Nine. It's 9. 12 squared root of 2x. If oh, this is such a cancerous thing. 4x plus 2. Right, 4x plus derive this 4 times and multiply it by here. Put this at 12. If dash g, take away g dash. So derivative of this is 4x plus 2 times 0.5. Another square root of 2x squared plus 2x plus 1. Let me just plug this into my calculator. 12 square root of 0.3017 squared plus 2 times 0.301 17, take away 4 times 0.3017 plus 2 times 4 times 3.017. Oh no, 0.3107. 3017 plus 2 times 0.50 over 3 square root of 0.3017 squared. 2 times 0.3017 plus 1, all of that squared, times square root of 2 times 0.017 squared plus 2 times 0.3017 plus 1, which is equal to 0.2384, which is greater than 0, therefore minimum distance. I hate cursed questions. Oh man, here's another cursed question. Question 4a. Oh man, these are extremely cursed. Viewers often have twin lamps during their lambing sections. On a New Zealand sheep farm, it has been observed that over time at intervals 0 to TP, the mean probability that both twins have the same sex is given by T equals 1 over TP integral from TP to 0 of P probability of male squared plus probability of female squared, all integrated by the relations with DT. So we can give PM all squared over is A take away B over TPT all squared, which is equal to A squared equal to A take away B over TPT plus A take away B all squared over TP squared T squared. And we for probability of female, we can just say 1 minus A minus B over TPT. This, we can just say this, and if we square that, 1 minus A plus A minus B over TPT all squared, which is equal to 1 minus A plus A minus B over TPT minus A plus A squared minus A brackets A minus B over TPT plus A minus B over TPT minus A brackets A B over TPT plus A minus B all squared over TP squared over T squared. So we integrate, these combine some like terms. So one of actually I guess I want more space here. So integral of 1 over 2p integral from 2p to 0 of a no, that combines minus 2a combines. Where can I combine other like terms? Minus 2a minus b over tpt. Oh no, that's it just becomes 1 because it just becomes 1 because of this. Wait, what? Actually, no, wait. Oh, these two fully cancels out. Ah, my. Ah. Right, so these two cancels out. Wait, what? Actually, does it? Was it? Yeah, I think it cancels out at least, hopefully. Plus 1. Minus 2a because a minus b with tpt plus 2a minus b all squared over b squared t squared, I believe. Cross this out, cross this out, cross this out. We integrate this in relations with dt. So wait. Did I forget? Wait, did I forget something? Wait, one. Wait, let me just redo all of this real quick. Wait, did I? So a squared. So a squared and a squared matches up together, and minus a matches up together. Minus 2a. Wait, minus 2. Wait, that's minus 2. Oh fuck. Oh no, this is minus 2a. This is minus 2a. Ah. It's 2a over gpt. No, so this. Right. A because minus tpt. Right, minus a minus. Oh no, but this also 2 of this, so this also goes in together. So that gives minus 4a pt plus this. I think that's a mistake. Plus 2 this would be over tpt plus 1 plus and this together. It's 2a minus b all squared over tp squared over t squared. Oh, I believe that was a mistake. Oh, I hate cursed questions. So we differentiate this in relations with t. So 2a squared t minus 2at minus 2a because a minus b over tp t squared plus a minus b over tp t squared plus t plus t plus a minus b all squared over t squared tp squared over 2 over 3 t cubed from tp to 0. To be fair, the zeros all just all the zeros just cancel out, so we just want to, so 1 over tp brackets 2a squared tp minus 2a tp minus 2a brackets a minus b tp plus a minus b tp plus tp plus 2 over 3 a minus b squared tp, so which is equal to 2a squared minus 2a minus 2, let me just expand that, minus 2a squared plus 2ab plus a minus b plus 1 plus 2a minus b all squared all over 3. Let me just get this back into, so let me just rearrange that. So 1, these two cancels out, minus minus a plus 2ab minus b plus 2 over 3 a minus b all squared, which is minus a plus b brackets 2a minus 1 plus 2 over 3 a minus b all squared, which is this absolutely cursed question. I believe this is another cursed question. The function f(x) satisfies the differential equation 4x squared dy over dx, y squared take away 2xy. Find the value of f4 given that f1 equals negative 6. You may use any valid method. However, the following techniques may be found for a substitution for y could be made. For example, y equals u x and a rational expression such as w over x because x plus b, where w and b are constants, can be written as w equals a over x plus b over x plus b, where a and b are also constants. So let's just make the substitution that Mr. Insu has told us to. So this means y squared is equal to u squared x squared. 4x squared dy over dx is equal to u squared x squared. Take away 2 brackets u x x. Then we can differentiate this. So using product rule, derivative of u is we can get by implicitly differentiating. So we differentiated in relations with the x, so d over dx x plus u is equal to dy over dx. So for x squared du over dx x plus u is equal to u squared x squared take away 2ux squared. So du over dx x plus u is equal to u squared take away 2u over 4. We can a over dx is equal to u squared minus 6u over 4. Then we can use separation of variables, so 4 over u squared take away 6u du is equal to over x dx. We can integrate both sides. So here is where the trick comes in. So we can split 4 over u squared take away 6u to a over u take away 6 plus b over u, which is equal to au over plus bu take away 6b over u brackets u take away 6. The constants match up, so a plus b u and minus 6b. So there is 0u, so this is equal to 0, and there is 1 4. Just match up with the constants and coefficients. So if there is a u squared, then they match. If there was a u squared, we would have matched it up with u squared. So b equals minus 6b equals 4, b equals minus 2 over 3. So a plus b equals 0. So a equals 2 over 3. So we can put it back into this here. So 2 over 3 brackets u take away 6. Take away 2 over 3u is equal to, we can integrate this. Integrate this is equal to integral of 1 over x dx. 2 over 3 natural log of absolute value of u take away 6 is 2 over 3 natural log of u absolute value of that equal to the absolute value of natural log of x plus c. We can pair them up, so 2 over 3 natural log of u take away 6 take away natural log of u is equal to natural log of x plus c. Natural log of u take away 6 over u is equal to 3 over 2 natural log of x plus. Do I want to create it? Do I want to? Okay, 3c over 2. So it's so remember we made the substitution y equals ux. So actually, will it be easier? Y over x is equal to u. So if 1 is equal to negative 6, so u, in this case, negative 6 over 1 is equal to u. So u, which is negative 6. So natural log of negative 6 take away 6 over negative 6, absolute value of that is equal to 3 over 2 natural log of 1. Yes. Plus 3 over 2. Actually, I just keep it Wait, do I want to keep it? Yeah, actually, I want to keep it in terms of the original Oh, no, do I? Let me just log of 2. Actually, this is 0. Actually, no, I want it to create a new constant, so, um, um, uh, 6 minus 6 over minus 6 equals 3 over 2 natural log of 1 plus c. So that we want to keep the natural, so the constant is natural log of 2. So 2 over 3 natural log of u take away 6 over u equals, actually no, I don't, 3 over 2 log of x plus natural log of 2. So we want to find f4. So actually I might just substitute natural log of y over 4 minus 6 all over y over 4 is equal to 3 over 2 natural log 4 plus natural log of 2. Because of log rules, we can put this to here. Natural log of 3 over 2, which is equal to natural log of 8. So natural log of y over 4 take away 6 over y over 4 equals natural log of 8 plus natural log of 2, which is equal to natural log of 16. Then we can just kind of, because natural log of y over 4, 6 all over y over 4 equals natural log of 16, we can kind of just ignore these two. Y over 4 take away 6 is equal to 16 brackets y over 4. Y take away 24 is equal to 32. Oh, no, that's... No, those two just cancels out, so 16y, I believe. Wait, is that correct? Yeah, okay, so minus 15y is equal to 24. Y is equal to, is that negative 1.6? Negative 1.6. Therefore, if 4 is equal to negative 1.6. Curse questions. The curse questions continue. Okay, so question 5a. So w take away 1 over w plus 1. So cosine theta, so I sine theta take away 1 over cosine theta plus I sine theta plus 1. So so since it says I tan theta over 2, this gives us kind of a hint that we're going to be using the half angle rules. So let me pull out my formula sheet. So cosine theta, this can be rewritten as where is it? Where's the half or double angle rules? Yeah, so cosine theta over 2 can be written as, so we want to get rid of this negative 1 kinda, so we're gonna use 1 minus 2 sine squared theta over 2 and this I sine theta over 2 can be rewritten as I 2I sine theta over 2 cosine theta over 2. Let's rewrite this as, I want to get rid of the 1, so we write this as 2 cosine squared theta over 2 minus 1. So, and we write this as here. So, just equal to 1 minus 2 sine squared theta over 2 plus 2I sine theta over 2 cosine theta over 2 minus 1 all over 2 cosine squared theta over 2 minus 1 plus 2I sine theta over 2 cosine theta 2 plus 1 cancels 2 sine squared over 2 minus plus 2I sine theta over 2 cosine over 2 all over 2I sine 2 cosine theta to 2 sine squared theta 2 plus oh no, that's cosine. Is it? Do I just? I think. We can factor an I from here and an I from here, so which gives I sine theta over 2 plus cosine theta over 2 all over and actually I don't think we need to so cosine theta 2 cosine over 2 plus I sine theta over 2. These two cancels out, which leaves, and this cancels out, I sine theta over 2 over cosine theta over 2, which is equal to I tan theta over 2. Oh, that's very lovely. We're actually going pretty fast. Question 5b. Oops, sorry. In the parametric equation, x, y, a cosine theta by sine theta is ellipse a unequals to b. The parameter theta is not the same angle as the angle phi at the origin, although it is often mistaken for this. The two angles theta and phi are, however, closely related. In particular, they are the same at the x and y intercepts. Find the equations relating to theta and phi. So here, is it alpha or b or a? Just say a. Oh no, that's b sine theta, and this way is a cosine theta. Then I think we can just, this is phi, so tan phi is equal to b sine theta over a cosine theta. So tan phi is equal to b over a tan theta, which we can kind of see is very closely related. Yeah. I think. Wait, I think theta is always greater than phi. Is it? Yeah, theta should usually be greater than phi. I think. Let's see. Yeah, I think so. So different. So we want theta to take away phi. Yeah, we want to get So if theta is equal to 10 of theta take away phi, this we can get the other equation. So we can use one which angle was it? Yes, compound angle. So 10 theta minus phi is equal, so just equal to 10 theta minus 10 phi over 1 plus 10, yeah, 1 plus 10 theta 10 pi 10 phi. And remember we got 10 phi, we can replace that, so 10 theta minus b over a 10 theta or over 1 plus 10 theta b over a 10 theta. We can multiply the top and bottom by a, so 10 theta minus b 10 theta or over a plus b 10 squared theta. How can we write this easier? Yeah, let's just factor out 10 theta. 10 theta is equal to a plus b 10 squared theta. That's what if theta is equal to. So, we derive this. So, the derivative of 10 is secant, I believe. So, if dash theta is equal to sec squared theta, a dash, if dash brackets a plus b 10 squared theta take away a minus b 10 theta. Right. Wait, how do I do right? How do I derive from 10 theta f dash g plus g dash f. How do I do f that? 8 6 squared 10 theta plus so that's 2 10 theta 6 squared theta. Actually there's a 2 in front here. 6 squared theta. Oh wait, there's a b here as well. 10 theta. Oh wait, let me just rewrite this. So minus 2 minus b 10 theta times derivative of that, which was b2 b10, which is b. Oh, that becomes 10 squared. 10 squared. Theta. 6 squared theta. Wait, here, let me just stick a b in here. Over. To be honest, the denominator actually doesn't matter because the denominator actually doesn't matter. So this is equal to 0. So the numerator is 0, so 6 squared must be a plus b. A plus b 10 squared theta minus 2b a minus b 10 squared theta. Um, 6 squared theta. Wait, where did I? Wait. 2b a minus b 10 squared theta squared theta. Yeah, this equals to 0. A minus b a plus b 10 squared. Wait, 6. Oh wait, oh no, wait. Plus, wait. Oh no, lost, things got lost in translation. We need to remove this. A plus a minus b a plus b 10 squared theta. So we factor out 6 10 squared, and we can also factor out a minus b from here. This times a plus b 10 squared theta. 10 squared theta minus 2b10 squared, 2b10 squared theta equals to 0. Cursed Christians. So a minus b has to be either a minus b has to be 0, but we know that in an ellipse a unequals b. So this then 6 squared theta equals to, if 6 squared theta equals 0, then 6 squared theta is actually 1 over cosine theta, cosine squared theta, and that can never be 0. So the only possible way is for this to be 0. So a plus b10 squared theta minus 2b10 squared theta is equal to 0. A minus b10 squared theta is equal to 0. Equals b10 squared theta. A over b equals 10 squared theta. 10 theta is equal to a over b plus minus square of that. And theta will be equal to inverse 10 of plus minus square root of b over a. Yes, that. I am pretty sure that is the answer. Hopefully. Okay, that is the end of the exam. Thank you for watching. And that was quite painful